The areas of triangles and trapezoids. Before we dive into this and start developing the formulas for these, what I want to do is go back and just recall the definition of area. Area is literally the number of square units that you can fit within an enclosed region. For example, I've got a couple pictures of triangles here, and you could start to count the squares that are inside of it. However, you do have these partials. You do have partial squares. And in some of them, like that little weird spot right there, it's not really obvious what you would end up doing with that one. So the neat thing that we're going to do is develop formulas for shapes based on preceding shapes. So far what we've come up with are area formulas for rectangles and parallelograms. And the trick to the triangle is to notice that if you have two congruent triangles and you set them up adjacent to each other, you can actually build a parallelogram, a shape whose area we know how to calculate. And to do that, all you need to do is rotate one of them, just rotate one of them over, match it up to the corresponding side that would be congruent. And you have yourself a picture of a parallelogram. Okay, now when we calculate the area of a parallelogram, that would be calculated using the base times the height. Okay, so the base of the parallelogram is the same base that we have from the triangle. The height of the parallelogram is also the same height that would be taken from the triangle, which I don't have shown in the actual figures here, so I'm going to go ahead and add that in. Okay, so the height just has to be a perpendicular to the base. Let's go ahead and call that base. This would be height. Same thing would be true for the other triangle. Okay, so when we put those together, we can calculate the area of the parallelogram by multiplying base times height. But in truth, if all we want is the area of a triangle, just one of these, we can take the area that we get from the parallelogram and divide it by 2. The triangle's area is half the area of a parallelogram with the same height and base. So formally stated, the area of a triangle is going to be equal to 1/2 base times height, which you can also present as base times height divided by 2. Either of those will work, just depends on which one you want to use. Conveniently, the area formula for trapezoids can be found using the same process that we did for the triangles. We start with two congruent trapezoids, which I have shown here, and if we position them correctly, we can create a parallelogram. Then based off of the area formula for the parallelogram, we can adjust things just a little bit to get the area formula for the trapezoid. Okay, now the difference between a trapezoid and the triangle is that you do have this top flat side here, which is also going to be referred to as a base. Okay, so in a trapezoid, you have two bases. You have base 1, you also have base 2. Whichever one you call 1 and 2 doesn't really matter, but you will have two different bases, and there will be different lengths. If they were the same length, we would have a different shape. And in addition to that, we need to have a perpendicular. We have the height shown here. A perpendicular is something that you're going to need to have for every area formula. Okay, so if I take these two trapezoids and I flip this one, if I can, all right, so if I flip that one over, match it up over here, I get a parallelogram. Likewise, I could move that to the other side if you want to see it that way, so it really doesn't matter. Okay, but I have myself a parallelogram. And to calculate the area of the parallelogram, what I would do is multiply the base times the height. In this case, though, the base of the parallelogram is not B1 or B2. It's not one of the bases of the trapezoid. It's actually the sum of them, because you've got B2 here, and this is the other one just flipped over. So B1 moves to the bottom. Let's go ahead and add that in there. So that'll be B1. So the area of the parallelogram is going to be the sum of the bases, B1 and B2, multiplied by the height of the trapezoid. The trapezoid's area is half the area of a parallelogram with the same height and a base equal to the sum of the trapezoid bases. That would be B1 and B2 together. So in summary, the area formula for a trapezoid is 1/2 B1 plus B2, the sum of the bases, multiplied by the height. Or if you prefer, you could write it this way. which is exactly the same thing. Another really neat way to look at this though, and try and keep this in mind, is that B1 plus B2 divided by 2, that part of the formula is literally the average of the bases. So if you had the mid-segment of a trapezoid, which would be a line going from midpoint to midpoint, whatever that length is, that would be 1/2 B1 plus B2. So if you had the mid-segment length, you could actually just multiply that by the height, and it would also give you the area of the trapezoid. All right, for example 1, we're asked to find the area of a triangular sail. The good news here is you are provided the base and the height. The base is 13 feet 4 inches. The height is going to be 12 feet 2 inches. So the unfortunate part is that you're working in 2 units, that you have feet and you also have inches. There's a couple of approaches that you can take with this, but the one I'm going to begin with is thinking of these as mixed fractions. The 12 feet 2 inches is the same thing as 12 and 2 parts out of 12. You have 12 inches in 1 foot. The 13 4 inches is 13 and 4 parts out of 12. So if I take their product and multiply that by 1/2, I do get the area. So I'm going to begin by looking at the fractions that I got here. And unfortunately, 2 out of 12 is not a nice number. Okay, and 4 out of 12 is also not really a nice number. However, to get pretty close to the right answer, what I could do is take those decimals and just round them off. And that's what I'm going to do for my first approach. Okay, so I'm going to have 1/2 times 12.17 times 13.33. Okay, so let's see what that looks like. The 1/2 I'll just type as 0.5 times 12.17 times 13.33. And I get a little bit more than 81. And what I'm going to do is just go ahead and call that 81.11. Okay, so this will be 81.11 square feet. The second process that I'm going to use might be a little bit confusing because there's some things that we haven't talked about yet that apply to this. But I'm going to go ahead and give it a shot. What I'm going to do is convert everything into inches. The process here was to convert things into feet. Okay, but I can also convert things into inches. To convert the 12 feet 2 inches into inches, what I need to do is first convert the feet into inches. Every foot is going to have 12 inches in it, so I can take 12 times 12, which is 144. 144 plus 2 will give me 146. So that is equivalent to 146 inches. So as an alternative approach, I got 1/2 times 146 inches times, and we'll see what this is, 13 times 12 is 156. 156 plus 4 will give us 160. So if I run this calculation, 0.5 times 146 times 160, I will get a large number because I'm going to be figuring out the number of square inches in the sail. Okay, so that turns out to be 11,680 square inches. Then the trick to converting it back into square feet is not to divide by 12, but to actually divide by 12 squared. In every foot, in every square foot, you've got 12 inches. I'm not going to mark that off exactly, right? But you got 12 inches by 12 inches. So if you were to extend out, and again, I didn't count these, okay? But if you were to extend out across a square foot, marking off at every inch, you would end up with 12 by 12. You get 144 square inches. So if I divide this answer by 144, I get the same answer that I did beforehand, except more exact, because I didn't round partway through there. So we still get 81.11 feet squared. All right, for example 2, we're going to calculate the area of a trapezoid. The area formula is 1/2 the sum of the bases times the height. Okay, things that we have. We've got a 5 and we've got the 7, we got our bases. So that's going to be 1/2, 5 plus 7, which we can just call 12. The height. The height is not there, right? We don't know the distance from R to Q, which would be the perpendicular to the bases. But we do have one other piece of information, which is that 60-degree angle. So how can we use that to figure out the length of RQ? Because once we get that, we can then just put that number here and wrap this whole thing up. Well, the trick is to draw the height in a different spot. To draw it here. We're going to go ahead and make a perpendicular there. And when we do that, this creates a rectangle, which means that from this point to Q is going to be worth 5 units. So from P to that point, we've got 2 units. And now we have a right triangle with an angle of 60 degrees and 30 degrees, if you want to use that, and you do know one of the sides. And even though we have a shortcut for the 30, 60, 90 triangle, there's a possibility that you might work another problem that does not involve 30 and 60 degrees in there. So a way that we could do this regardless of what type of angle measurement we're given would be to use trigonometry. So thinking about the right triangle, what we want, this height here, just call it H, that height that we want is opposite of the 60 degrees. The value that we have, the 2, is adjacent to it. So that would be a tangent problem. The tangent of 60 degrees will be equal to the opposite divided by the adjacent, H divided by 2. In other words, H is going to be equal to 2 times tangent 60. You just multiply the 2 across. All right, so now we'll go to the calculator for that. Make sure that we're set for degrees, which we are. Type in 2, tangent 60, and we get 3.46. And we're going to have no choice but to approximate it. Now, if you did use your special right triangle shortcuts, you could express that in terms of a radical, which would be 2 square root 3. Okay, so that's something that you could check out if you want. This is the same thing as 2 square root 3. Okay, but let's just go ahead and take that number and plug it in. Let's see what we get. So I'll leave that answer in my calculator, times it by 12, divide it by 2, and we get approximately 20.78. And these would be meters squared. In exact form, if we took the 2 square root 3 and plugged that in, the 2 would cancel with that 2 and give you 12 root 3. Okay, so if we're good with an approximate answer, we could use that. If we're very particular about this being a 30, 60, 90 triangle and would like an exact answer, you could use this.
Later, blah.